Here's another example of conditional probability, or as we call and probability, when you have multiple events. So if you want to pause the video so you have time to kind of read and soak in the question, feel free to do so. So we have a couple measures here. Now, one, don't be fooled. Make sure you're reading everything carefully. We're all conditioned nowadays to skim, but you've got to read. We can see that 65%, it jumps out at us, but down here we have another percentage. It's just hiding in the phrase 1 out of 4. So 1 out of every 65% are female. Of those, that's an important phrase, 1 out of every 4 works in the health field. So they're only talking about the females. 1 out of every 4 is the fraction 1/4, which is 25%. So they gave us 2 percentages there, really. They just hid the second one. So that's our problem. We have a couple probabilities here. Find the probability that a randomly selected person from that jury pool is female. So female, and there's our and probability, works in the health field. Okay, so we know how to do and probabilities. We need to get the probability of each event and we multiply them together. So in this case, the probability was given to us as a percent and not a fraction. So we're going to use that here. It's just when we calculate with percentages, we have to change it to a decimal. So the probability of somebody being female is 0.65. Now technically, when you do what's called and probability, it's really the probability of the first one. So I'm going to put F for well, or female, times the probability of the second one, given that the first one has happened. So this is our symbol for a given statement. See that little line in between two things? And that's what we have here. It's what we had in the cards too. Remember in the without replacement ones, our second fraction, it was actually a given situation. Given we left a king out of the deck. Now our second fraction is different. Well, given that we selected a female, the probability that they work in the health field, that's 1 out of every 4, which is 0.25. And we multiply those two together. So in your calculators, you got 0.65 times 0.25. And the probability of that occurring is 0.1625. That's the probability that you randomly select somebody who's a female that works in the health field. That's important if you're a lawyer and it's a case that involves anything related to health. Okay, that was a silly comment. But anyway, that's how they really do use probability and statistics like this. The law degree is filled with it. Find the probability that someone selected is female and does not work in the health field. So we have an and probability, which means I need 2 probabilities that I'm going to multiply together. It's female and not health field. I know the probability of getting a female, that's 0.65. I know when I am and situation, I multiply. Not being in the health field, that's when I've got to use the rule of complements here. So if you'll remember, the rule of complements is 1 minus the probability that you're talking about. So if I want not health field, it would be 1 minus the probability of being in the health field. That's 0.75. So 0.75 is my second probability. Multiply those two together, and you get 0.4875. So when you have multiple events, and I might have had, well, anyway, that's just one example there. All right, let's look at another kind of, just our last sort of multiplication probability. So what I have here is something your app on your phone might tell you for the next 3 days, a weather forecast. So I've got the chance of rain each day. So notice Saturday, July 19th, chance of rain of 80%, then 50%, then 30%. And my question is, based on that forecast, what's the probability it will rain all 3 days? So you might look at that and say, oh man, it's going to rain every day for the next 3 days. But let's look at the probability. So now we have 3 events. We're talking about 3 different days. I like to set up my little lines here. And I want the probability that it rains on day 1 and rains on day 2 and rains on day 3. And I know the probability of each, and the probability doesn't change based on what happened the day before. So the probability that it rains on Saturday is 80%, so that's 0.80. Probability of rain on the second day is 50%, 0.5, and then 0.30 for the last one. But the probability that it rains every single day, all 3 days, I have to multiply those three together. And that will give me the probability that it's going to rain every single day for the next 3 days. And that's only a 12% chance. Isn't that shocking? Like, we all look at the forecast and we say, oh man, it's going to rain every single day. But based on that weather forecast, there's only a 12% chance that it will rain every single day. Just as a follow-up, I kind of like this question. I won't type it out there. You'll just have to hear it. But and I'll write it in symbols. How about that? What's the probability of there being no rain for that 3 days? That it will not rain Saturday or Sunday or Monday. So you might be thinking, oh, that's rule of complement, and I just do 1 minus 0.12. But you can't do that, and here's why. If I were to do 1 minus 0.12, that's the complement of rain all 3 days. Well, there's a lot of things that can happen between rain all 3 days. There's rain day 1, rain day 2, and not rain, right? It might rain on one of the days and not on 2 of them. Or it might rain on 2 of the days, but then not rain on the 3rd. So these are not our only 2 options. It's not either rain on all 3 or no rain on all 3. You might have, again, rain on some days, not on others. So that's why these 2 are not complements, and I cannot just do 1 minus 0.12 in order to get the answer to my second question. For 2 things to be complement, they have to be the only 2 options available. So how are we going to solve my problem? Well, we're going to solve it the same way we solved the first. I just want to erase some of this stuff here. We're going to solve it the same way we solved the first one. We're going to get our 3 fractions. Let's get a brighter color here. And we're going to multiply our probabilities together. Probability that it does not rain on Saturday. Well, I'm going to use the rule of complements for that. The complement of 80% is 20%. Together, that makes up 100%. So there's 20% chance that it will not rain on Saturday. There's a 50% chance that it will not rain Sunday. And there's a 70% chance that it will not rain on Monday. So you're doing 100% minus each of these. So the probability that it won't rain on any of those days, 0.2 times 0.5 times 0.7. There's only a 7% chance of that, so it's not great, but it is possible. So that's just another twist on that same problem.